Alright, talking about section 1.4, continuity and one-sided limits. So we have some definitions here. We have two types of discontinuities. There's a removable, which is we sometimes call a hole, and there's non-removable, which is either an asymptote or a jump discontinuity. Alright, moving on to the examples I'm going to do for this section. We want to determine it should be if the following, not of. If the following are continuous on a given interval. So we're going to do this by graphing. You need to be able to graph these by hand. Sometimes you'll also be able to graph them on the calculator, but you need to be capable of graphing them by hand and understanding how those graphs look. So the function is 1 over x. We have a vertical asymptote at 0. Alright, we're looking at the open interval from 0 to 1. So we have to be very careful about what we're being asked here. We graph that. We know there's a vertical asymptote, which is at x equals 0. So there's that discontinuity there. So it's tempting to say that this is not continuous. But we were asked only about the open interval from 0 to 1. And this is continuous on the open interval from 0 to 1 because we're omitting x equals 0 and x equals 1 from that interval. So it is continuous on that interval from 0 to 1. The next function is x squared minus 1 over x minus 1. And we're looking at the open interval from 0 to 2. So when we graph that, we see that we have a hole or a removable discontinuity at x equals 1. The interval that we're looking at is from 0 to 2 on the open interval, and 1 is on that interval, so this function is not continuous on the interval from 0 to 2 because it has that discontinuity or that hole at the point 1, 2. Next example is we have f of x equals the sine of x, and we're looking for all reals from negative infinity to infinity, and we know that sine is a continuous function.